demonstrated we could use the method of tangents to determine the instantaneous speed at a number of times. Our next step in analysis is to use these to estimate the acceleration of the object. To do that, we need a speed versus time graph. To do this, I'll start by inserting a new tab. We'll rename it to speed, and then we'll set it up with time and speed. We include the appropriate units. Although we only have a few points, I will use formulae to make setting this up quicker. Equals A2 plus 0.5. I can then click and drag this to fill the column. I know we only have 4 values, but demonstrating this can be useful when we have more. We started at rest, and we'll then copy our values from the previous example. 3.14, 5.87, 8.92 and 13.3. Although this is only a limited data set, it should be enough to demonstrate the acceleration. Again, we'll use a graph, and we'll use the scatter graph. We'll make it larger so we can see. We'll update the title, speed versus time, add some axis titles, time, and speed, and we'll update our markers. Again, the crosses show us a nice accuracy. We can see the intersection while still being reasonably visible. And again, although not really necessary, we'll add the minor grid lines. Our final step is to actually add a line of best fit. Add a trend line, and straight away we can see that a linear trend line is a reasonable fit. The data may curve, but it appears that there is a general linear trend. We'll set the intercept to be 0. We don't need to forecast backwards because our data already include the 0. And we may as well make it black just to make it visible. One final trick we can use is to actually display the equation on the chart. That automatically calculates the slope of the line for us. In this case, we can see that y is equal to 6.32x.